Welcome participants. This lecture is on demonstration of lysimeter. Lysimeter, in theory class we have discussed different types of lysimeters and drainage type of lysimeter will be demonstrated in the field. You will also see in the field weighing and non-weighing type of lysimeter. So, types of lysimeter for determining evapotranspiration requirement of the crop. We will show you in the field run of monitoring system from horticultural field plantation crop. You will also be shown groundwater level measuring system. Now, all these parameters are important for water management studies, irrigation studies or water balance studies. So, let us go to the field and try to learn these two types of lysimeter. One is weighing type lysimeter and non weighing type lysimeter in the field. In theory class, we have explained about lysimeters. Lysimeter is the device which is used to measure evapotranspiration requirement of the crop. We have learnt in the theory class there are two types of lysimeter. One is weighing type of lysimeter, another one is non-weighing type lysimeter. In weighing type lysimeter, the entire soil sample on which the crop is grown or plant is grown, it is kept on a floating material, that is, it could be a water, it could be heavy metal. So, any deflection due to change in soil moisture content, due to precipitation, due to irrigation, that is reflecting in the change in the value of displacement of the liquid. So, here in this particular class, I am explaining you a laboratory model, where one can find out evapotranspiration requirement of the crop. This is a rose plant, which is grown in a earthen pot, and the earthen pot is filled with the soil, and then this rose plant is grown. Now, this is placed over a base, and below the base there is a rubber cell. A rubber cell which is coiled, it looks same as scooter tire. Now, when we are filling water, it increases, it flattens, it goes up water level because of the water level. So, it expands, and the connection is made in such a way the water from the outlet, it is connected with a measuring scale. Now, this measuring scale, it can be made vertical, but this scale is made on a inclined manometer tube. Inclination is provided to get more sensitiveness and the increase in the length of the expansion. Now, one of the most important part is that this base should be perfectly level. So, by using the spirit level, we are placing here and we see that the water bubble, it is exactly at the center. It means this particular base is perfectly level. Now, what I want to show you here, suppose I am growing a plant and in this plant we are giving water. Now, water can be given by using a cylinder. Now, if we are giving extra water, part of this water will go out, but it is a perfectly made in such a way we will not give extra water, and also we do not allow the water to go beyond the root zone depth. So, any amount of water which is being added in this particular pot will be remain in the soil, that will cause increase in the moisture content level, and this moisture content which is taking place, it will be used by the plant for meeting its evapotranspiration requirement. Now, when we are adding water, means soil is gaining. Now, this gain is reflected in the change in the water level in the inclined manometer. Right now, if I see I have not added water, the at particular level this is a 40 millimeter. At this particular point it is 40 millimeter. When this particular plane is made inclined at 15 degree. Now, here there is a provision, if we want to increase the sensitivity, we can further bring it down. If you want to increase means from 5 degree to 30 degree, there is a provision, we can change the angle, and at this particular point I am taking observation at 15 degree angle. Now, let us see that I want to add water. Now, add water means just in place of water, what I am doing, I am putting 200 gram weight. Now, by placing 200 gram weight, there is a change in the water level. So, initially water level, let me just see, the initial water level is 45, it is about 45 millimeter. Now, when I am placing 200 gram, means certain amount of water which is equivalent to 200 gram, let us say it is added to the plant, there is a change in the water level, and that change in the water level is reflected as 65 millimeter. Now, let us say that we are still plant needs more water. So, I am adding another 200 gram. So, by addition of another 200 gram, the change in the water level means there is a increase in the water level, which is nothing but increase in the soil moisture content, I can say, because I am just putting these weights in terms of analogy, I am putting in terms of adding water into the soil sample. Now, once I am adding water to the soil sample, now this value it has increased the moisture content to 90 millimeter. Now, further if I am putting another 200 gram, means further I am adding water. So, it has become from 95 millimeter to 115 millimeter. So, 20 millimeter is the change in the water level which is reflecting here. Now, let us say this much amount of water, that is equivalent to 600 gram of water has been added to the soil. Now, plant will be using this water for meeting the evapotranspiration requirement of the crop. Here what I am telling here, I am just putting one thing, I am not giving any additional water which is going as surface runoff. I am not allowing water to go beyond the root zone depth. So, water is remain in the soil as in the form of soil water content. So, now I am just seeing, means after 24 hours, let us say next day I am coming and then I am observing whether how much amount of water it has been withdrawn by the plant. So, I am taking out water, let us say 200 gram water it is taken out. So, 200 gram water when I am it is taken out, the value it has changed, it has come to 97 millimeter. So, 97 millimeter means the whatever the value it was there initially. Let me tell you, it was there initially about 120. Now, it is 123 millimeter, 123 millimeter, and when I am taking out 200 means next day when I come here and I take observation, I find that now this reading is 97 millimeter. So, from 120 to 97 millimeter, this much amount of water is lost due to evapotranspiration requirement of the crop, because I did not allow any water to go beyond the root zone depth. I did not allow any water to go as surface runoff. So, this is the water which has been used by the plant for meeting the evapotranspiration requirement. Now, again I am taking out, means another 20 after 24 hours means after 48 hours, let us say I am coming for observation and I observe. So, 200 means there is a withdrawal of water, this has been taken by the plant, and then I find that there is a difference in the value. Now, this difference in the value is now I find here it is 673 millimeter. So, from 97 millimeter to 73 millimeter it has come. So, this is the equivalent amount of water which has been consumed by the plant for meeting the evapotranspiration requirement. So, like this, this particular gadget need to be calibrated, that at what will be the range, say in a particular angle. In a particular angle, right now I am putting about 15° angle. So, what is the range that water level will fluctuate, and then this has to be calibrated. Then second part is we can keep on giving water, and then we can find out how much amount of the water once we are putting water with the help of, now just now I will show you, say this is another 200 gram I am taking out, and then observation is 52 millimeter. Now, I will put water, and just it will show you that I am putting water here. Say this is right now it is you can see it is a 1500 ml. I am putting just simply water 1400 ml, means 100 ml of water I am adding. Right now, observation is this is 50 millimeter. Water level in inclined manometer is 50 millimeter at 15° inclination. I am adding 100 ml of water. sorry, it has already gone more than 100 ml. So, I am putting, let us say, another this is approximately, let us say, about this is a 1200, yeah, about 1300. So, 200 ml of water I have added and the reading was 50 millimeter. At present this reading it has come to 80 millimeter. So, 80 millimeter is the water level in the manometer, and next day when I come and take observation, I will take out this particular this and again I will put it. So, I will take observation and then I will see how much amount of water it is lost. So, it will be the combined evaporation and transpiration it has taken place from the soil, because you can see here no water is taken, it has gone beyond the pot and it has not spilled out. So, this 200 ml of water which has been added here, that can be seen that how much water it will be lost. So, that water will be consumed by the plant. This way one can find out what is the total water requirement for the entire season. If it is a long duration crop, if it is a accordingly the size of the container, accordingly the depth of container, volume of the container, that can be decided. We have fabricated 3 lysimeters where crops can be grown inside the lysimeter. We discussed about weighing type of lysimeter, where the entire part was floating above a rubber gasket. In this case, these lysimeters are non-weighing type of lysimeter, where different components of water movement takes place, that can be monitored. So, this particular lysimeter is of 1 meter long, 1 meter wide and 1 meter deep. It is driven into the soil and then the soil from the field is filled in. We have tried in these lysimeter to maintain same soil texture, same bulk density and same compaction. So, over the years when we have conducted experiment, we find we are able to replicate or create condition whatever the field condition exist in the adjoining area. So, same crop is being taken. We have taken in our experiment okra crop, we have grown moong crop, we have grown rice crop in the same thing to find out crop coefficient as well as evapotranspiration requirement of the crop. Now, these 3 lysimeters where we have we are collecting data. So, in one case in this particular setup, what we see that here it is a the bottom is kept open. So, in this one as well as in this particular lysimeter, the bottom is again it is kept open, and in this particular lysimeter the bottom is it is kept closed. So, this lysimeter when we are giving water, so water is being given with the help of micro irrigation system or even by by means so measured quantity of water is being supplied in the lysimeter. In all these three cases same. Since bottom is kept open, so evaporation means and without crop is not being taken. So, evaporation and then the water which goes beyond the root zone depth or beyond 90 centimeter of the lysimeter, it takes place from this lysimeter. Similarly, so evaporation plus percolation, these two components are taking place in this lysimeter, whereas in this particular lysimeter we are growing crop. So, and then this amount of water which we have given there, same amount of water is given in this lysimeter. So, what happened, the bottom is kept open. So, evaporation, because plant is or crop is being grown. So, transpiration takes place, and then also depercolation means water which goes beyond the depth of lysimeter, beyond the root zone of the crop, that is is considered. So, evaporation plus transpiration plus depercolation, all three components takes place in this one. Whereas, in this particular lysimeter the bottom is kept closed. So, bottom is kept closed, it is only the, and then no crop is being taken. So, amount of water which we are adding in the left or in the middle one, means the first one, or in the middle or second lysimeter, here same amount of water is being given, but it is kept, since bottom is kept closed. So, water remain in the lysimeter. So, it is only evaporation which will take place. So, if we want to subtract the total component, means evaporation plus transpiration plus depercolation loss, then I can know, I can subtract the evaporation which has taken place from this lysimeter, then I can know what is the evaporation, what is the transpiration plus depercolation. There is also a transpiration plus depercolation. So, these components individually it can be accounted and measured. Now, the in lysimeter we have placed soil moisture measuring instruments. So, there are two types of soil moisture measuring instruments, where we are using FDR, that is known as a frequency domain reflectometer. So, here this white, this particular pipeline which you see here, this is a access tube. This is a access tube, and access tube is driven up to the your lysimeter, even beyond the lysimeter. This is driven up to 1.2 centimeter. So, the what happened in this case, when we are giving placing the lysimeter, here you see there are these two electrical probes, and the arrangement it is made that this particular, it is a 10 centimeter. So, the electrical field means when we are giving high frequency current, when it is passed through, it corrects, it generates the electrical field, and this high frequency the current which is passed, it is function of the dielectric properties of the soil. So, dielectric constant of water is 80, and when it is a dry soil it is approximately 0 to 4, but as the moisture content of the soil it is more, it is getting it gets influenced. So, though the waveguide it gets influenced by the availability of the moisture content in the soil. So, here it is 10 centimeter as it is being shown. So, you can see here these observations are, this is first 10 centimeter, then we can take another 20 10 centimeter. So, the moisture content in the soil moisture in the soil at different depth, that can be monitored. Now, since already this tube is above the ground, about 10 centimeter above the ground. So, when we will take observation, say when we will place 20 centimeter, the observation what we will get, this observation will give amount biometric moisture content at 10 centimeter depth. So, here I am placing here. So, this is the value is 13.2 millimeter per centimeter per 10 centimeter. Now, I can place at say I am putting it at say it is a 30 centimeter. So, when it is a 30 centimeter, the value is 21.1 millimeter per centimeter. So, the water content, it is being it is coming in a linear unit, but this can be expressed in biometric unit also, in percentage it can be expressed. So, this is the one way of finding out the moisture content at a different depth in the soil, and so amount of water which is stored in the root zone depth, that can be measured by using field frequency domain reflectometer. There are several devices, time domain reflectometer, there are several other sensors which are available to monitor the soil moisture content. Now, when we are talking about when I was taking your class, so in the class theory class I was telling there are various components which takes place. One is how much amount of water which is aided in the form of irrigation. So, depth of water which is supplied to the lysimeter for meeting the evapotranspiration requirement, that can be a measured amount, it is being given. So, this we are it can be given, or in the form of rainfall, if something it is coming, that can be aided. So, that is a gain amount of water, and then water which is going as evaporation, loss as evaporation, this we are taking the balance in the values in 3 as I told you, and then amount of water which is going beyond the root zone depth. So, one has to monitor the water level also, if it is going to the water table level, then that can be measured by what means measuring the water table, or amount of water which is at different depth, that the soil moisture content, that can be measured. Another way of measurement of soil moisture content is by using tensiometer. It is by tensiometer. So, tensiometer is a device which measures the tenacity of soil, which is the water which is held by the soil particles. So, these tensiometers are available in different sizes. You can see here we have inserted one tensiometer. This is placed about 15 centimeter below the soil level, and this is the another. Suppose we were interested to find out the moisture content, and this is at the deeper depth. So, a tensiometer, it is a tube which is filled with water. It is filled with the water. The other end of the tensiometer, a common tensiometer, that is connected with a gauge. That gauge is a vacuum gauge which is giving the negative pressure or tension or suction we say. Now, in this particular tensiometer we have placed a a very special type of rubber membrane. This is a specifically made rubber membrane, and when we are piercing in a needle, it gives the how much amount of the tension it is available. So, when we want to find out soil moisture tension at different depths, we place tensiometer in the soil at different depths and then find out how much is the soil moisture tension at different depth. Now, this soil moisture tension is calibrated in terms of moisture content. So, there is a calibration curve which is used when we are taking data. So, there are a lot of the development it has taken place with the time. So, here these are also connected with some digital or pressure transducer based. In this one also I will demonstrate you, there is a needle. When we are placing the needle, when we are placing the means piercing the needle in the tensiometer, so it gives the observation, it gives the, so it is here it is giving 14 millibar. 14 millibar is the observation which we are getting the value of this means the tension which has been created. Now, 14 millibar is equivalent to how much is the soil moisture tension. This has to be calibrated, means at that particular the depth, means it is, as I told you that it is placed at 15 centimeter depth. So, soil sample is to be taken. Now, that soil sample is to be find out the gravimetric moisture content, and then this calibration curve means for the different soil moisture tension, and then corresponding soil moisture content will be obtained, and from the calibration curve one can find out what is the value of soil moisture tension. So, there are different devices which are available to monitor soil moisture content. So, amount of water which is stored in the soil as a soil water that is consumed by the plant for evapotranspiration. So, water which is available in the soil, that can be measured by any one of these device. It can be the FDR, it can be TDR, it can be granular soil moisture sensors, it can be, there are various gypsum type of soil moisture sensors, those are available. So, soil moisture content in the soil, and then water used by the plant by taking the balance of soil moisture content, taking the balance of evaporation component, taking the balance of depercolation content, one can find out what is the evapotranspiration requirement of the crop. Now, in field water balance, when we are doing, we are measuring various components. These components, when I was telling you, when the rainfall it occurs, so some part of the rain it will be absorbed by the soil through infiltration process, some part of this water will be absorbed by the soil as a soil water, which will be available for the plant for meeting its evapotranspiration requirement. Some part of the water it will go as a depercolation. Now, when the intensity of the rainfall is more than the infiltration capacity of the infiltration capacity of the soil, this water will go as runoff. So, let us see how the runoff monitoring is done, which we have set up here, where we are monitoring other component of hydrologic cycle, other component of field water balance, that is used for determination of evapotranspiration. In field water balance studies, to determine various component of water balance, so say input component as irrigation or precipitation as runoff. When it falls on the ground, some part of the water, it is appearing as surface runoff. So, say this is my horticultural plantation. Now, during rainy season, besides water, it goes through infiltration process, it is intercepted by the plant canopy, it is appearing part of the water, it is appearing as surface runoff. That surface runoff is measured by using appropriate device. So, here what we see from this horticultural plantation area of sapota crop as well as for the lychee plantation, this is about half hectare land in which these plantations have been made, and in this half hectare land we are providing irrigation water through drip irrigation system. But during rainy season irrigation is not given, but we want to know what are the different components which are playing, which takes place from these horticultural plants. So, runoff part what we see when it comes in this area, we see here there are 3 outlets. There are 3 outlets. So, water from the middle outlet is being collected in a collection tank, and water from the adjoining other 2 outlets from this area, it goes to the outside, and that is the outside channel it goes. So, when it comes to the middle pipeline, it goes to the collection tank. It is measured with the help of digital water level recorder. So, digital water level recorder, as it name it says, that it has a one end is a, you can say this is a counterweight, and this another end is float. So, as the water in the tank it will enter, it will cause rise in the water level, and this rise in the water level will cause the float to come up, and then counterweight will go down. So, this rise is measured in terms of whatever the runoff it has generated from this horticultural plantation, and this data these are in a digital form. So, this is what I was telling you, this is a pulley. In this pulley, one end is counterweight, another end is float, and then this is driven, and then here there is a battery, and then data which are coming, it is coming over here, and these data there is a provision that one can download the data in USB port, and that can be analyzed. So, we have collected these data for more than 5 years of the date, 5 years period, and then these data are used to compute how much amount of water it has gone in different processes of hydrological cycle or in irrigation water balance components. So, infiltration, depercolation, means we are monitoring the water level, groundwater level, amount of water which is appearing as surface runoff. So, all these components are there, and then it can be accounted in terms of evapotranspiration requirement of the crop. Runoff is influenced by several factors. One of the factor is vegetation cover. We have seen the horticultural plantation where sapota and lychee was existing, and then runoff water was being monitored for that type of vegetation. When agricultural crop, it is there where you will see it is a small height, short height crop which is covering the ground surface. It also influences the infiltration characteristics of the soil, it also influences the physical characteristics of the soil. So, runoff is also being monitored from agricultural crop field, where we are cultivating in this field rice, moong. We also cultivated vegetable crops such as okra, and then just few weeks back we harvested broccoli crop. Now, water, whenever rainfall it occurs, when excess rainfall it occurs, it generates the runoff. So, runoff is being monitored from such plot, and that is in the same manner which I explained in this one, that water, there are 3 outlet, there is one outlet exist here, there is another pipeline that is in the middle, and then the other one. So, out of the total runoff it is generated, it gets distributed to 3 outlets. So, 2 outlets it goes meet with the channel, that is the outlet channel, and then from the middle that is the center pipeline, it is connected to the water collection tank. Now, water collection tank, again it is means there is a digital water level recorder, and this digital water level recorder, it is the rise in the water level is monitored by when there is a change in the water level. So, float rises, and this means the rise in the float level is monitored in terms of digital value. The solar panel connected to each of these water level recorder, this provides the power source to operate the water level recorder.
Rolling action.
The another important component of water balance is deep percolation. So, water which goes below the root zone depth, and that water, if it meets with the water table, this causes a rise in the water level. So, we discussed about measurement of runoff from different types of covers. Here we also monitored runoff from the cashew plantation. So, we have a runoff monitoring gadget. Here the another component is monitoring of groundwater level. So, this groundwater level is being monitored on daily basis, that how much amount of water it is being used by the plant through root system by capillary action. In adjacent to this, there is a tube well. This tube well, when it is being operated, this we want to also know how much amount of water it is getting affected, water level is getting affected because of the operation of tube well in the for that is being used for irrigation purpose in our agricultural engineering department experimental farm. We do monitor, and we want to know that how much water it has gone in the groundwater when we are recharging. So, in this particular area we have made a trench, and this trench is basically meant for the water whatever is going in the trench as a surface runoff. So, this gets deposited in the trench, and that causes a rise in the water level. Now, I will demonstrate you when we are measuring the water level, how water level from a piezometer. So, this is one piezometer which has been installed like this, adjacent to this there is another piezometer, and those are small other smaller pipeline that is kept at the shallow level, and these are quite deep. So, at deeper level these piezometers have been installed, and I will show you what is the current water level in the piezometer. So, right, the observation is 6.3 meter. So, 6.3 meter is equivalent to about 20.6 feet. So, water level at present in the my experimental area, which is the Kaju plantation, that is a cashew plantation area, where we have observed that it is at 20.6 feet. So, these data means runoff data, the groundwater level data, soil moisture data, evaporation data, transpiration data, all these are used to compute evapotranspiration loss. So, in this particular field demonstration, we have learnt two types of lysimeter, weighing type of lysimeter and non-weighing type of lysimeter. Non-weighing type of lysimeter which we installed, we have used for variety of crops to determine its crop coefficient. We have published papers from non-weighing type of lysimeter. We have monitored runoff, that also it was shown to you, digital water level recorder, where runoff generated from horticultural plantation crop, where sapota, lychee and other crops also. So, similar gadget is used for monitoring the runoff which is taking place from any micro watersheds, and then groundwater level measurement, whatever the water table rise or depletion in the water table it takes place, that also we demonstrated you. Now, in forthcoming lecture we will have a tutorial class on evapotranspiration requirement and crop water requirement. So, thank you very much for your patience hearing.